All right, guys. So, any questions over the homework? So we worked with these yesterday. We did these, so and I feel like for the most part we felt pretty comfortable with them. Now, what we did talk about this a bit. Simplest form. It is going to be good to rewrite this because we will be using and referencing simplest form for today. With radicals, no radicand have perfect nth powers as factors other than 1. So what that's saying is we can't leave the square root of 8. Because 2 squared does simplify out of it, we have to rewrite it. We do have to simplify it as 2 square roots of 2. Because if a number inside the radical can reduce, we need to reduce it. No radicands can contain fractions. We cannot have a fraction inside of a radical. So the square root of 3/4, we cannot leave it at this. We have to go through the process, and we end up with 3 square roots of 2, or square root of 3 over 2. And number 3 is kind of the same as number 2. We cannot have a radical in the bottom of a fraction. I can't leave it as 1 over the square root of 2. We have to use our simplifying steps, and we actually end up getting the square root of 2 over 2. Cannot have radicals in the bottom of the fraction, cannot have fractions inside of radicals, and if a radical can reduce, we need to reduce it. Questions on this here? Okay. Product property, if we have 2 things being multiplied inside of a radical, we can split it into 2 separate radicals with the same root. Conversely, if we have 2 radicals being multiplied together with the same index, same root, we can merge them back together into 1. If we have 2 radicals being divided, or have something being divided inside the radical, we can split it up into 2 radicals, top and bottom. Or vice versa. So we want to use the properties of radicals to simplify each expression. Cubed root of 12 times cubed root of 18. We want to simplify this as far as possible. Now, one of the first things I would want to do is factor 12 and 18 as far as possible. So we're going to do some factor trees to simplify this here. 12, we have 2 times 6. 2 is prime, so we can look at 6. 6 is 2 times 3. Telling us that 12's prime factorization is 2 squared times 3. 18. We have 2 times 9. And 9 is 3 times 3, telling us its prime factorization is 2 times 3 squared. Thus meaning the cube root of 12 is the same as the cube root of 2 squared times 3. Cube root of 18 is the same as the cube root of 2 times 3 squared. And the reason I do this is because we're looking at cubics. We're trying to see what times itself 3 times is part of this here, or factors of these 2 numbers that can be represented as a number times itself equal to the index, equal to what root we're taking. 12 does not have a cubic, or a number times itself 3 times as a factor, and the same is true for 18. We can't reduce either one. However, according to our product property of radicals, it says we can multiply what's inside those radicals together. Yes. So what we can do at this point is multiply these together. Now we can write this out independently because it'd be 2 squared times 3 times 2 times 3 squared, because we can multiply what's inside together. But realistically, our 2 squared times 2 is going to be 2 cubed. Our 3 times 3 squared would be 3 cubed. Then if we wanted to, we could break it back apart, saying that we're taking the cubed root of 2 cubed times the cubed root of 3 cubed. Well, the cubed root of 2 to the third is just going to be 2. The cubed root of 3 to the third is 3, and 2 times 3 is 6. Cube root of 12 times cube root of 18 is indeed 6. So if it works out nicely, the calculator will do it for us. It'll tell us that this is indeed 6. There's a good chance if we take the 4th root of 80 and divide it by the 4th root of 5, we will indeed get a nice number. Now, if we look at the prime factorizations of these here, well, 5 is just 5. It's already prime. 80. Well, we have 2 times 40. 40 is 2 times 20. 20 is 2 times 10. 10 is 2 times 5. So its prime factorization is 2 to the 4th times 5. Now we can divide these two together. I can make it 1/4 root of 2 to the 4th times 5 over 5. Because normally we wouldn't want a radical inside, or a fraction inside this radical. But by putting a fraction inside the radical, we do have 5 divided by 5, which would be 1, telling me I'm left with the 4th root of 2 to the 4th, which would be just 2, which the calculator would also tell us. Now, yes, there's other ways we could have done this, because I could have ignored the factor tree to begin with and said, I know that 80 divides by 5. And just rewritten it as the 4th root of 80 divided by 5, which is going to be the 4th root of 16. 16 is 2 to the 4th, which tells me it is 2. So there's multiple ways we can get to the answer. Or we can just plug that in the calculator and it would tell us it was 2. So sometimes the nice thing to do, the 4th root, or the cube root of 4 times the cube root of 128, might be to just try plugging it into the calculator and see what we get. Tells us it's 8. Because 4 is nice, it's just 2 times 2. 128, 2 times 64, which is 2 times 32, which is 2 times 16, which is 2 times 8, which is 2 times 4, which is 2 times 1, 2, 3, 4, 5, 6, 7. It's telling us that we have the cube root of 2 squared times the cube root of 2 to the 7th. Product property says that's the cube root of 2 squared times 2 to the 7th. Since we're multiplying like bases, we would have the exponents giving us 2 to the 9th. How many groups of 3 2's can I take out of 2 to the 9th? 3. Now, nth root of a to the x is equal to a to the x over n. So if I wanted to, it's kind of nicer to see it this way, is this is the same as 2. 9 would go on top because it's the exponent, and the root is 3. So we're saying the cubed root of 2 to the 9th is the same as 2 to the 9 thirds. 9 divided by 3 is 3. And 2 to the third is indeed 8. So it's almost the cubed root of 2 to the 9th. We're just taking that 9th power and dividing it by 3. Every whole group comes out. Every fractional group, that many stay in. But that's it. Questions on this here? I have a feeling you already plugged this in, figured this one out. What did you get? Okay. Because 192, does it divide by 6? Does 192 divide by 6? So, I mean, the main way we can check 192 is even. 1 plus 9 is 10, plus 2 is 12. 12 is divisible by 3. So those should divide evenly. And since they divide evenly, might as well merge them and then divide 192 by 6. And it gives us 32. So there's a good chance that's going to be 2 to the 5th. And the 5th root of 2 to the 5th would be 2. So this is nice. We can just go cubed root of 135, and it gives us an integer value. It doesn't. All the ones we've done up to this point have given us these integer solutions. But since this one doesn't, we are going to definitely have to factor tree it to see how this reduces. When I start, I always start with small numbers that I know that work. So 2, 3, 5, 7, some of the prime numbers. Later. So 2 is definitely not going to work because it's not even. 1, 3 is 4, 5 is 9, so there is a factor of 3 in this. And if we're not sure, I can go 135 divided by 3 is 45. Well, 45 is divisible by 3. It's 3 and 15. 15 would be 3 and 5. Telling us 135 is 3 to the third times 5. So that means we can come over here and replace 135 as 3 to the 5th times 5. Now, if we're not sure we got the factor tree right, 3 to the third times 5 is indeed 135. Questions on how we got to this here? Product property of radicals says I can split this. Cubed root of 3 to the third is 3. Cubed root of 5 is just 5. I do not have enough 5s for it to reduce. So we're saying that the cubed root of 135 is 3 cubed roots of 5. That's it. Questions on those here? 5th root of 7 divided by the 5th root of 8. It's not going to simplify. One thing we would check and see, do I have some divisibility on top and bottom? Because if I can reduce it, it might make things nicer. However, we do not. Now, I know if I have 8 to the 5th, the 5th root of it would reduce and simplify out, yes? However, before you jump into doing that and doing it that way, can I rewrite 8 as a number to a power? Yes. And 8 is what? 2 to the third. Because 8 as a factor tree would be 2 times 4. 4 is So we could have tried to rewrite it as 8 to the 5th, but that would actually have been 2 to the 15th power. We'd been way too big, which means those multiple factors would come back out and simplify back out. On top, we have the 5th root of 7. That hasn't changed. Any questions on this so far? Now, what we would like and what would be nice is if this denominator was the 5th root of 2 to the 5th. Because if I had the 5th root of 2 to the 5th, that 5th root and 5th power would reduce out. They would simplify down. We wouldn't have anything else to work with. It would be simplified. Because that's the big issue at this point. One more. No radicals in the bottom of the fraction. We don't have 1 or 2, but we need to find a way to get that to be there, yes? How many more 2's do I need on bottom? 2. So what we can do is I can multiply the bottom by the 5th root of 2 squared. Because when we multiply like radicals, we multiply what's inside. I have 3 of them. I multiply by 2 more, so we do have a total of 5, yes? But if I do it to the bottom, I also have to do it to the top. Which means on top here, I have the 5th root of 7 times 2 squared. Fifth root of 2 to the 5th will indeed be 2. Do 7 and 2 squared share any common factors? Shouldn't. 7's prime, yes? And the reason I'm mentioning that is if anything would reduce on top, if we could take the 5th root of it. Because if we can, we have to. That's why doing 8 to the 4th is not helpful, because we're adding perfect nth roots to the top, which have to be factored out and will be simplified out. But here, no. At this point, we could do it by hand, or I can say 7 times 2 squared, which is 28. Telling us that the 5th root of 28 over 2 is the simplified form. Do we see what we did there? In the whole process of this here, it seems a little excessive to get it to 2 cubed, but we're wanting to make sure we don't have any extra perfect nth roots that we're throwing in. It's going to make things nicer. Because realistically, multiplying the top and bottom by 8 to the 4th, I want to deal with 4096. We ready for the next one? Well, at this point here, we have a good feeling that the cubed root of 500, the calculator is not going to like it. I look at prime factors first to try, because 5 times 100 would get us there, yes? 100 is 2 times 50. 50 is 2 times 25. 25 is 5 and 5. So the prime factorization of this here is 2 squared times 5 cubed. Now the cubed root of 5 cubed is going to be what? 5. Can I take the cubed root of 2 squared? No, there's not enough 2's. So we'll write it next to the 5, but I'm not going to write it as the cubed root of 2 squared. We're going to write it as the cubed root of what? 4. Since I know 2 squared does not reduce, it doesn't simplify, we're better off just saying it's 4. Let's put it back into a non-prime factorization form. Nice and neat. Questions on the cubed root of 500? 4th root of 19 over the 4th root of 4. Nineteen's prime. Then divide by 2, because that'd be 2 and 9.5. 3, not going to be a factor. 4 is going to be 4-point decimal number. We have all of our factors that we could have possibly had. However, the denominator, 4 is 2 squared. Now, what's interesting with this here is this, the 4th root of 2 squared, is the same as the square root of 2. Which feels like, and the reason I'm mentioning it, seems like, okay, this must be important, this must be key. It will not help us in this case. For me to be able to put two radicals together, they have to have the same root. They have to have the same index, yes? So even though on this one here, I could rewrite that denominator as the square root of 2, the numerator is still 4th root, which means I cannot multiply it by a square root and have what's inside multiply together. So here, this does nothing for us. But it is something interesting to note, because that means if I take a 4th root of 4, it does have the same value as the square root of 2. 4th root of 4. Interesting note. But how many more 2's do I need on bottom? 2. So I'm going to multiply the top and bottom by 2. 4th root of 2 squared. And the denominator will indeed give me the 4th root of 2 to the 4th. And on top, I'm going to have the 4th root of 19 times 2 squared. Now, again, we'd be looking for factors of 2 in 19, because if, for whatever reason, the numerator had 2 factors of 2 with it, that would give us a total of 4. It would simplify out. But it does not. 76. Telling us that the 4th root of 76 over 2 is our final answer. And the goal for this here is just trying to simplify those radicals as far as possible. And we cannot have radicals in the bottom of the fraction. So, again, we can't leave the square root of 3 in the bottom of that fraction. So, I'm going to pick something. Definitely a random number. I'm just going to change the sign in the middle. And we will have to multiply it on top. But for the time being, let's distribute the denominator. 5 times 5 is 25. 5 times negative square roots of 3 is negative 5 square roots of 3. Square root of 3 times 5 is plus 5 square roots of 3. That's looking nice for us because now I have negative 5 square roots of 3 and positive 5 square roots of 3, which means this is going to be what? 0, yes? Square root of 3 times negative square root of 3. We do know it's going to be negative. Square root of 3 squared, which would be 3. Or we'd have the square root of 9, which is still just 3. What happened to our radicals? They're gone, yes? Which means this denominator, 25 minus 3 is ready to multiply the numerator. 1 times 5 is 1 times negative square root of 3. Now, if we wanted to, we could break this apart and say 5 over 22 minus square root of 3 over 22. These are both the correct answer. They might throw it to the front and say negative square roots of 3 over 22 plus 5 square over 22. Same answer. And we know with most things, the calculator is not always helpful when we get to this here. That is the same thing we got, isn't it? They just flipped the numerator. Instead of 5 minus the square root of 3, negative square root of 3 plus 5. Minus 2, right? Because we would multiply by the square root of 7 plus 2 on top and bottom. Well, the numerator is just going to be square root of 7 plus 2 because we're multiplying it by 1. Square root of 7 times square root of 7 would indeed be 7. Square root of 7 times positive 2 is plus 2 square root of 7. Negative 2 times square root of 7 is negative 2 square root of 7. And negative 2 times 2 is negative 4. Questions? Four minus the square root of 2, 4 over square root of 2 minus 3 square roots of 5. 5 square roots of 3. 2 radicals, there's no way. Okay. For the most part, these will do it just fine. We also know how to actually do it ourselves. You can do it either way. But that's it.